Acha. So coming in the second phase of the class, I'm starting the class again. Yes. So I was discussing this part that just wait a minute. Yes. So I was discussing in the last part, that is the types of loading. The UDL. So for the UDL, the total load is W into L, and the bending moment W into L into L by 2, where L by 2 is the length. L by 2 is nothing but the length of the CG. Okay. Okay. So this part is there. Now coming to for UVL. Where UVL is used in uniformly varying load. For example, so where is the practical application of UVL? It is in hydrostatic force, fluid pressure, hydrostatic fluid pressure, hydrostatic fluid pressure where the load is not same. So in this case, we use the UVL, uniformly varying load. The UVL can be like this in right angle triangle form, or it can be in this form, like a uphill, like a triangle. So the UVL can be in this form also. So the UVL can be in this form also. Okay, uniformly varying load. Even though you don't have, the the UVL for a B.Tech level in a large scale. Okay, but just wait a minute. So the UVL is very interesting. So what is here UVL? Uniform is uniformly varying load. That is, you don't have any uniformly load intensity. Load intensity is not uniform here. It is varying. So the highest load intensity is given here. Load W Newton per meter. Highest load intensity, and is gradually decreasing. Similarly, here also W per meter. Highest load intensity W per meter. So what will be the total load? So here we will have to find out the total load. Load is nothing but the area of the triangle. Area of the triangle. Okay. So this is if I consider L. Okay. So the total load is half into height into base into height, half into W into L. The total load. So this is the total shear force. Whenever I will discuss about the shear force in UVL, that will be nothing but the half into base into height. Half in base is the length and high is the load intensity. Okay, height is the load intensity. So height W, obviously small w, keep in mind the small w is nothing but a load intensity half into W into L. That is the area of the triangle. Achha. Now coming to the CG, we have to find out the CG also for bending moment. Achha. For bending moment, first we have to understand the CG point. Now for CG point, all of you should know this. I will teach you in CG chapter also. CG and a moment of inertia. CG. Okay. So the CG distance for right triangle, if this is L by 3, then this is 2L by 3. That is from the tail. If I consider this is a tail of the triangle and apex of the triangle. From the tail, it is 2L by 3, and from the apex, it is L by 3, the CG distance. So, whenever you will find out the bending moment, first the bending moment will be load, half into load into distance, half into W into L, into the CG distance from where you are finding out. Into the CG distance from the point of concentration. From the point of consideration. Okay. So what is the CG distance? If I take this A is the apex. From the apex it is L by 3. So from the tail it is 2L by 3. From tail the length is more 2L by 3. Where L is the length of the total triangle. 2L by 3 from the tail and L by 3 from the apex. Okay? If you remember the CG distance, then no problem will have. Here in this case, if you consider in this triangle, this one, then the CG will be this point. Okay. Here, the CG will be simple L by 3, L by 2. Okay. So, keep in mind what type of UVL it is. If it is right angle triangle form, then it is L by 3. And if it is triangle in this right hand side form, then L by 2. Now, another type of triangle if we have, for example, the triangle is to the left hand side. If I consider the triangle is in the right hand side. Okay. If I consider the triangle is in the right hand side. Okay. So in this right hand side, the CG will be like this. Here L by 3 from the right hand side and 2L by 3 from the left hand side. There is a CG distance. So this is nothing but the CG distance which I am showing you. Very important for bending moment. Mainly we require this CG distance for bending moment. Okay. Now coming to another type of load, concentrated moment. If we have concentrated moment, for example, a moment is given at one point. Instead of load, a moment is given at that point. Then what will happen? At this point, the bending moment changes. Very important. At this point, keep this in mind. This will help you to solve or to have a concept at this point of concentrated moment. Clockwise on anti-clockwise doesn't matter. At the point of concentrated moment, for example, at a point instead of load, there is only moment. Then the bending moment sign changes. The bending moment changes. Okay. The bending moment changes. No change in shear. No change in shear. Okay. No change in shear. Fifth part, if you want to check, you can see this uniformly distributed moment. It is mainly for GATE or any competitive exams, but not for your normal B.Tech level. Okay. So for B.Tech level, you will have loading type 1, 2. If you see here, loading type 1, loading type 2, 3, and 4. Maximum 3 and 4. Okay. So keeping this in mind, let us now start. First, we will start with very simple question, small question. Okay. Now here is a semi-supported beam is this called semi-supported beam. All of you know. Simply supported beam, one roller, one pinned. Keep in mind. For semi-supported beam, at one end, it is a roller support. And at another point, it is pin support. Okay. So for this type of semi-supported beam, here the question is coming. Find out the reactions at A and B. So always in case of semi-supported beam, we always have to find the reactions at end A and B. find reactions at support. Find reactions at support A and B. Always I will teach you cantilever beam also, but to find out the reactions at support, you have to find out the reactions at A and B. We will start with the support reaction. Okay. So here also RA and RB. Now, since in this case both are similar, if you see here, the point load is L by 2, so it is symmetrical. So it is a symmetrical simply supported beam. It is a symmetrical simply supported beam. Okay. So RA is simply nothing but whatever the load is there, load divided by 2. Here also RB, whatever load, total load is there, load divided by 2. Total load is P only, the point load at mid-span, that is by P by 2. If it is something other span, I will teach you. That also I will teach you. Okay. Now imagine if the span is point load is not at the midpoint, then what will happen? You see here, this is the condition I am talking about. Let the point P is here, distance A and distance B. Distance A and distance B, AB are the support. So point P is not at the midpoint, so it is not symmetrical. First understand, it is not symmetrical. Okay. Since it is not symmetrical, first we have to have two unknowns, RA and RB. So whenever we have two unknowns, if the beam is symmetrical, no problem, nobody. But if the beam is not symmetrical, then we have to use two unknowns, two equations. Keep this concept in mind, very interesting and very easy. Two unknowns are there, RA, RB. RA unknown, similarly RB unknown. Reaction at A and reaction at B unknown. So therefore, similarly, we need two equations. Two equations required. Okay, two equations required. Okay, the first equation is total upward load. Upward load is RA/RB coming from down to up. So RA/RB, the upward load is equal to downward load P. This is equation 1. This is equation 1. Okay. What is second equation? We have to take, so this is nothing but this equation RA plus RB equals to P. That is nothing but this equation sigma Fy is equals to 0. Sum of the forces in y direction is 0. Upward load equals to downward load. Okay. Now, the second equation, summation of moments about A, either at A0, or you can find summation of moment about B0. Summation of moment at A0 or summation of moment at B0. Okay. So what will you find out the moments? So here in this case, I always told you, in truss also, in arches also, in beams also the same case. Clockwise moment equals to anti-clockwise moment. Clockwise moment is equals to anti-clockwise moment. This is the equation. Clockwise moment is equal to anti-clockwise moment. So therefore, the equation turns, if I take MA, summation of moments A equals to 0, That means I'm fixing the point A0. I'm fixing it. Just imagine you're putting a finger here at point A. So anti-clockwise moment. So due to the P, it is clockwise moment. So due to P, if you consider the what should I say? The direction P. So A is left. So due to direction of P, it is clockwise. Okay. And due to RB, it is anti-clockwise. Okay. So P into A, the clockwise moment, is equals to anti-clockwise moment RB into A plus B. Either you can use this equation or you can use the concept of so clockwise moment P into A, load into distance, plus anti-clockwise moment RB into A plus B, or the concept of bending moment. So in the bending moment, what was our sign convention? If we see the sign convention back here, see here, clockwise moment right hand side negative, and clockwise right hand side negative. So mainly we are checking the right hand side, and clockwise right hand side clockwise. So right hand side anti-clockwise is positive, and right hand side clockwise is negative. So here clockwise P. So due to clockwise it is negative. You can write down minus PA, and clockwise is clockwise is negative. See here. See, clockwise right hand side negative, and right hand side anti-clockwise positive. So clockwise minus PA, anti-clockwise, so plus RB into A plus B. To take the whole equation equals to 0. That also the same thing. The same thing we can write. Either if you are not very much comfortable with sign convention, then you can put clockwise moment equals to the anti-clockwise moment. Or if you are comfortable with sign convention, then clockwise on the right hand side negative and clockwise is positive. So you just put in one equation and you will get the answer. So from here, you will get the value of RB, and similarly you will get the value of RA also. Obviously, P should be known, or else it will be in terms of T. So see here, so basically in this case, so the equation is PA into RB into A plus B. If we find RB, if you cross multiply, what was the equation? PA whole divided by A plus B, right? So PA by A plus B is nothing but P into A plus B is the total load length L. So this is the shortcut trick you can apply in your competitive exams. RA is equal to total load by total distance into the distance of the opposite side. Very interesting. If you use this equation, here earlier it was A, it was B. So the equation was RB equals to PA into L. So RA or RB, whatever. So for RB, it is total load P by total distance L into distance of the opposite side. So RB opposite is A. And similarly, RA also same thing. P by L into the opposite side is B. So this is a shortcut you can apply for any competitive exam. Shortcut. Okay. Now similarly, same thing here as I told you, at unequal distance, RD hoche, see here, at unequal distance, RA, total load P by total length L into opposite length L by 3. Opposite of A is L by 3. And similarly, RB also, P by L into 2L by 3. Okay. So we can, for any simply supported beam, it is a point load. Next, I will come with UDL also. So this is the trick. At unequal distance, this if you remember, if you able to remember, then within 1 minute you can solve any MCQ. Or if you are not able to solve, then you apply these two equations. Two unknowns to equation 1 and equation 2. This one. No problem, it will take 2-3 minutes more. Now, so same for UDL also. Okay, UDL I will come to that. Let me come to the, slowly I will come to this question first. For UDL also the same thing. Even the UDL I will show you but later on details. So find out the reaction RA and RB. So total load is what? It is simply supported beam. Total load is, the load intensity is W into L, right? And it is symmetrical again. If you see here, it is a symmetrical. Why symmetrical? Because I have the whole load distributed throughout the length. So it is symmetrical beam and only the total, imagine you are holding a scale with your 2 fingers. So UDL W, total UDL, no partial, full UDL is there. The total load is WL. And similarly, we can say RA nothing but the load is distributed between the two reactions RA and RB. WL by 2, WL by 2. Similarly, here in the UBL case, UDL, simple, total load in whatever load is coming, that is simply W and L is the load by 2. W into L by 2. Afterwards, I will come to the shear force bending moment. That is next case. Okay. Now for UVL, already I told you for UVL that here the total load. Total load is this one. First, always carry total load, because when you have to find the reaction at supported reaction bar korte gele ki hobe, first you need the total downward load. Okay, capital W, that is half into base into height, half into W into L. Now reaction A and B, so already CG is shown, I told you, L by 3. This distance is L by 3, so this will be L minus L by 3, that is 2L by 3. Okay. In the same case, here it is not symmetrical. Okay. Even though it is simply supposed to be symmetrical, so two equation, two unknown. RA plus RB is equals to first WL by 2. It is equation A. Second equation, summation of A equals to 0. Okay. So RB into L is equals to, very interesting, RB into L into, there is the anti-clockwise moment. RB into L is the anti-clockwise because with respect to A, B is upward B, so anti-clockwise. And due to this triangular load, clockwise. So clockwise moment is total load into the CG distance. This is anti-clockwise, RB into L. You have to check to be which point you are fixing. You can fix at point B also. Same we will find. If I fix point A, anti-clockwise is B. So RB into L, total length is L. And clockwise moment, due to this triangular load, so total load WL by 3 into L by 3. Why L by 3? Because it is the CG distance from A. Okay. Now, if we do the other way, summation of moment B equals to 0. take at B, then also same case. If I'm taking at B, then RA into L, that is the clockwise moment, equals to anti-clockwise downward, then triangle. Same thing, W into L by 2, that is the area of the load of the triangle into, now from point B, what is the series distance? 12 by 3. দেখতে হবে যে কোন পয়েন্ট থেকে আমার সিজিটা লাই করছে। You have to find out from where the CG is there. So RA, so here in this case, so here, imagine this is the case, no problem. RA, RB. Okay. RA, RB. Okay. And we have the load triangle here, like this. Okay. And I am showing the CG with the blue line. Blue CG. Okay. You are now, in this case, you are fixing B. So put the finger here at B. What is the clockwise moment? Okay. So due to RA, we are getting clockwise. And due to triangular load, we are getting anti-clockwise. So RA into L. L is the distance between A and B. L. So RA into L is equals to WL by 2 into twice L, because from this end B it is 2L by 3. Okay. So this is the thing. So here RA, if you get L gets cancelled out. So and 2 also gets cancelled out. So RA is WL by 3. RA WL by 3, and similarly RB is coming WL by 6. WL by 6. RA is WL by 3 and WL by 6. If you add these two, this will both come as WL by 2 only. Just check. RB is WL by 6, RA is WL by 3. If you add this is nothing but the total downward load, that is WL by 2. Very interesting and very easy chapter. Now, due to moments also, just look at this. We can go through them. Now I will come to the questions further. Okay. First, I will talk about cantilever beam with point load. Then I will come with this question. Okay. So whatever sir have given you this question, I will discuss. All questions, whatever are there in the question bank, that I will teach you. And fluid mechanics, if your professor have given any other question bank, any other question, any extra question, already I have got questions from Suchana. If any other question they have given you, please send me the PDF in the WhatsApp group. Okay.
Okay, sir.
Okay. Case 1. I will start the fluid mechanics from next week only. Okay? So we are doing strength of material lot of days. Now we start with fluid mechanics. First 2-3 classes I will teach you fluid statics and all these questions, barometric, all these questions, barometric pressure, all these. Then I will go with, as students ask me, I will start with the open flow channel. Then I will teach you the flowing pipes. Okay. Cantilever beam. Okay. Now cantilever beam under point load. See here, case A. Very nicely it is given. Your main thing should be to make a chart. Okay. Cantilever beam with point load, cantilever beam with UDL, 0.2. Okay. You can write in your copy, make a chart of questions, so that in your copy also. Cantilever beam with point load, point A. Just write your headline if you're writing any one copy. Cantilever beam with point load at free end. Then cantilever beam with UDL. These all questions come in interview as well as MCQ. Cantilever beam with UDL over the whole length. Okay. Number 2. Cantilever beam with UDL over the whole length. Then cantilever beam with UVL. Okay. This UVL. Then semi-supported beam under this point load at midpoint. Okay. Then UDL, semi-supported with UDL. Okay, and semi-supported with 2 points. These are all standard things. So whenever I will teach you and I will send you the question, I will send you the PDF, please make a chart of the formula. Okay. Cantilever beam with point load. See how the things are coming. Let me teach you, then I will solve the question. See, A is a fixed end, B is a free end. And I am considering XX is the section. XX is the section which is X distance from B. So shear force XX is P because on the right hand side, the load is P. On the right hand side, our load is here. If you check these steps also, on the right hand side, shear force XX. To be more correct, you should write R for right. Okay. Shear force right is right side downward plus P. Okay. Now this shear force at any section, at XX section, if shear force at fixed end, it is not a function of distance. So P is constant. Shear force at A also P. Shear force at B obviously it's P because at point B, point load is acting. Wherever the point load is acting, obviously that will be the shear force. Okay. In throughout the section, we can see it is not a function of distance. The shear force is not a function of the length. Okay. So shear force constant. Shear force constant, see here, the same load P. Now bending moment about XX distance, P into the distance X. Now downward load, we can see here, P right side downward, so clockwise, so minus Px. Now, obviously minus Px. Now bending moment at B. At B, what is the value of X? X is 0. No value of load because I am starting the X from B only. B থেকে X value start হচ্ছে. So from B, if we are approaching, if I imagine you are walking from point B to point A, you are having a evening walk. So at point B, X0, 0 means minus P into 0, 0 bending moment, no bending moment. So see here, at point B it is 0. The bending moment at A. What is A? The value of A is X equals to L. We have reached the whole distance L. So minus P into L. So the maximum value. Obviously the sign should be there. Shear force diagram, value and symbol should be there. Okay. So end A is towards left. On the right hand side, you have point P. XX is the arbitrary section I have taken. Now I am varying the X. If X is 0, that is point B, point P, shear force P. X is equals to L, shear force P only because no X is there, only no function of length. So shear force is constant. Bending moment minus P into X. Now at B, X is 0 because it is just starting. So I cannot put X as 1. I can just put X 0. So 0 means bending moment 0 at free end and at fixed end maximum bending moment minus P into L. So see here, it is not an equation, it is a linear equation. Linear equation. That is y equals to ax plus b. It is in the form of conforme. It is in the form of y equals to ax plus b. So that is the length, the line is linear. এটা কিন্তু খুব ইম্পর্টেন্ট, বুঝতে হবে যে দ্য লাইনটা লিনিয়ার কেন, নট ইট ইজ কার্ভ। Why it is not curved? It is linear because it is using the simple linear equation y equals to ax plus b. ঠিক আছে? So it is see here. So p into l, simple linear equation, no square, no cube is there. So simple linear. And very interesting, you can see here this point. MB, moment at B minus moment at C is nothing but the area of the shear force between B and A. Moment at B minus moment at C is nothing but the area of the shear force between B and A. Okay. So this is the cantilever beam with point load. Okay. So this is same diagram. Here the fixed end is left, A fixed end is left and free end is B right. In this case, fixed end A is towards right or free end towards left. Okay. These I have taken from another book also. Okay. The same thing. Shear force, please keep in mind it will be, since they have taken from the left, so shear force is minus. Mainly the shear force becomes plus actually. Plus P into L. Chain convention, okay. They have taken a load towards left. Now see here. This as a simple example, example 1. You can go through this example 1. Okay. So bending moment, let me teach you. This you can do yourself. I will teach you this question. Achha, UDL is also there. So let me teach you the UDL one. UDL. Cantilever with uniformly distributed load, UDL. So whenever UDL is coming, okay, imagine this point end A and B. B is free, okay. So we have UDL load. UDL load. W per meter. W per meter, okay. So whenever we will do the shear force bending moment diagram, always keep in mind we have to, using pencil, always remember using pen, pencil and scale, always draw a diagram like this. One diagram at free end B, one dotted line at an intermediate point of UDL because we need the CG distance, and one at the fixed end. 1 minute left. After that, again, after 5 minutes, I will tell you to rejoin. Okay. So see here. First is shear force. Okay. So in the calculation, you will give the heading shear force calculation. As please I tell my students, on the left hand side, you always draw the diagram, and on the right hand side, you will do the calculation. This is the best way to solve shear force bending moment. This is the trick I found out from my IIT professor, IIT Bombay. He told me to 10 years back to draw the diagram on the left hand side and do the calculation on the right hand side. Draw it small, no problem. Okay. First, shear force. We all know bending moment is function of shear force. So first, not bending moment but shear force.